Namaste, welcome to Pythagoras Academy. This is Vikram Dachepally. In this video, I will try to explain the concept of spring force. Spring is nothing but a thin metal which is coiled up. Now, when the spring is subjected to stress, it will either elongate or compress. When the spring elongates or compresses, there are elastic forces developed inside the spring, which is known as the spring force. All the elastic forces developed inside the spring combined together, we call it as a spring force. If you look at the basic structure of a solid, the atomic structure of the solid, the atoms of the solid are like, they have got their mean position, like it's like as if they are on the corners of the cube and they're vibrating about their mean positions from their respective positions. So all the atoms are vibrating. This you might have studied in solid state of chemistry. Now when the spring is compressed or elongated, what happens is these atoms naturally will tend to come back to their original positions. In the process, the elastic forces are developed. So the elastic force, the resultant elastic force developed inside the spring is known as spring force. So the aim of this spring force is to bring the spring back to its original length or the natural length. Atoms coming back to the original length implies spring is getting back to its natural length. So that is the reason if you elongate the spring will try to come back to natural length. The spring force will be a pulling force. It will pull. So if you connect a spring to a block and if you pull this block down, the spring force exerted by the spring on the block would be upwards. It will try to pull it back to come to natural length. Suppose if you compress the spring, say you are compressing the spring, if you're pressing the spring inwardly like this, then the spring is trying to come back to its natural length. So the spring force will be a pushing force in this case. So the direction of spring force is decided by the factor that you have compressed or elongated the spring. If you have elongated the spring force is a pulling force. If you have compressed the spring force is a pushing force. Now, for example, say you are stretching the spring by, say, a length x, natural length of the spring is L. Then we have this equation, Young's modulus is stress by strain by Hooke's law. If we apply Hooke's law on the string, a spring will obey Hooke's law. Stress by strain. When you elongate, let me say the spring force developed inside the spring, that is F by area of cross section of the spring, that is A. Strain is elongated length x by initial length L. So this is nothing but F into L by A into x, which is Young's modulus. So spring force F is equal to YA by L into x. This is the spring force which is developed when you try to elongate, or the same thing applies when you try to compress the spring by a length x. It is very clear that the spring force developed inside the spring is proportional to the change in length x. Greater is the compression or elongation, greater is the spring force. Now, y is a constant. Suppose it is a steel spring, it has got a defined Young's modulus which is constant. If it is a copper spring, it has got certain Young's modulus which is constant for a given material. And A is constant. Once you have got the spring, the area of cross section of the spring remains constant. Length of the spring, you have chosen spring of certain length, L is constant. So all these constants, YA by L, I'll replace with a single constant K and I'll write it as K into X, where K is Young's modulus into area of cross section by L, which is known as spring constant, or it is also known as stiffness constant. And the units of this spring constant would be obviously Newton per meter. K is F by X, it is Newton per meter. And it is so obvious that the stiffness constant of a spring is inversely proportional to length. For example, if you have a spring of stiffness constant 100 Newton per meter. So what does it mean? What does the stiffness constant imply? To elongate or compress the spring by 1 meter, a force of 100 Newton is required. 100 Newton force is required because 100 Newton force is developed within the spring to get it back to natural length, right? So that is the meaning of 100 Newton per meter. To cause a strain of or the elongation of 1 meter, the force required is 100 Newton. Now if you cut the spring into two halves, so if you cut the spring into half, length is half, so stiffness constant is doubled. Then if you cut the spring into half, the stiffness constant becomes double, so K dash is 200 Newton per meter. So when you cut the spring into two halves, each half will have stiffness constant varied and which is double than the initial value. So this is the spring constant. Now suppose a block is suspended freely with the help of a spring, it is in equilibrium. Now if you draw the free body diagram of this, the weight of the block is acting downwards because the spring is elongated. The spring force is in the direction of pull. Let me say it is, if the stiffness constant is K, so K into X, in equilibrium Kx is equal to mg, the elongation caused in the spring is mg by K. This is how you find the elongation of the spring. And a very important thing to remember is that spring force can be in the direction of pull or in the direction of push. Elongation, it is in the direction of pull. Compression, it is in the direction of push. So this is all about spring force and the stiffness constant. Hope you understood this. Thank you. If you have any questions or queries or suggestions, you can always use the comment section to interact with me. I'll be more than happy to respond and receive your feedback. This is Vikram Dachepally signing off. Namaste.